Many important problems in mathematics have the same shape. A linear operator is given, and for a given target vector the equation is to be solved. The condition for a solution to exist is exactly that the target lies in the range of the operator. Suppose we know how to recognize that range. Then we may as well make it the new codomain, and so assume the map is surjective. But what solving the equation means still has to be pinned down. The principle running through all the important instances is this. A solution process computes a right inverse of t, that is, a linear operator back from the codomain, whose composition with t is the identity. Put another way, a solution process picks one solution for each target, and picks it so that the solution varies linearly with the target. Taking that as the meaning of solving gives a clean statement. The theorem, let T be a surjective linear map with null space n. Then a subspace is a complement of n exactly when the restriction of T to it is an isomorphism. And taking the inverse of that restriction is a bijection from all such complements onto all the linear right inverses. Now a different subject, polynomials in T. Given a polynomial and a fixed operator, replace the variable by the operator and a new operator results, where a power of the operator means composing it with itself that many times. The bilinearity of composition tells us that multiplying polynomials corresponds to composing operators. So any two polynomials in the same T commute with each other under composition. Addition is more direct still and carries over as it stands. So sending a polynomial to its operator preserves addition, multiplication, and scalars at once. A map preserving all the operations of an algebraic system is called an algebra homomorphism. The word is general. A homomorphism of vector spaces is a linear transformation. One algebraic fact is needed. When two polynomials are relatively prime, there are two further polynomials whose combination of them equals 1. The book assumes this and leaves the proof to algebra. One more word. A subspace is invariant under T if T carries it into itself. The theorem says that for any polynomial in T, its null space is invariant under T. And if that polynomial factors into two relatively prime factors, the null space is the direct sum of the null spaces of the factors. The proof turns the relatively prime equation into a pair of projections, and a corollary extends it by induction to any number of factors.